Hi, and welcome to Rational Expressions Day 8. Today we are going to add or subtract rational expressions, and when you're adding or subtracting rational expressions, you're simply just adding and subtracting fractions. The first thing you need to do is factor the denominator if possible. Any and all denominators that are possible, you must factor. Then you must find an LCD or rename the fraction. I should say and rename the fraction. Then we add or subtract numerators only. We never add denominators. Factor again if possible, and then reduce. So the first problem I have is 8y over 15x squared plus 9y over 15x squared. I cannot factor those denominators. My LCD is 15x squared because that's what they both have. So I don't need to find the LCD. I don't need to change my fraction. So step 3 is to add or subtract numerators only. Well, I have 15x squared as my denominator because that's not going to change. 8y plus 9y is 17y. And then it says to factor again if possible. Well, that's not factorable. And 17 and 15 do not share a common factor. Therefore, you cannot reduce it. So it is done. For number 2, I have 4 over x minus 2 plus 7 over 2 minus x. Well, my LCD here is just going to be x minus 2. X minus 2 and 2 minus x are related to each other. We know that if you multiply by negative 1, you will get the reverse. So it's just going to be plus x minus 2 and then 7. And I need to multiply that by negative 1 to get it to look like x minus 2. So I really have 4 minus 7 over x minus 2. So I have negative 3 over x minus 2. For number 3, my LCD between 3 and 2 is 6. So in order to make 6, I must multiply the top and bottom by 2. So I have 2 times 4x plus 1 minus 1 over 6. I have to multiply 2 times 3 to get 6. So it's 3 times x minus 5. So distribute in the numerator, and I will have 8x plus 2. And then here I need to be careful because that negative side needs to go with the 3 when I distribute. So it'll be minus 3x plus 15 all over 6. So now I combine like terms. 8x and minus 3x is 5x, and 2 plus 15 is 17. Then I look to see if 5, 17, or 6 have common factors, and they do not. Therefore, I am done. For number 4, this one is a little bit different. I have a 1 minus x and an x. Well, my LCD is 1 of everything I see. So I have an x and a 1 minus x. So I have a 5 over 1 minus x, and I need to multiply top and bottom both by x. Minus x times 1 minus x. Well, the second fraction was missing a 1 minus x, so I must multiply the top by 1 minus x. Whatever I multiply the denominator by to get the LCD is what I must also multiply the numerator by to get the when I got the LCD. So my numerator becomes 5x, and remember to take this negative along with you. So it's negative 1 plus x all over x times 1 minus x. Combine like terms in my numerator, and I have 6x minus 1 over x times 1 minus x. Cannot reduce, cannot factor, nothing cancels out. Therefore, I am done. Number 5 is the first time we actually have to worry about factoring our denominators. I have x squared minus 4, which is just x plus 2, x minus 2. So My LCD is 1 of everything I see, so it's x plus 2, x minus 2. And it doesn't matter the order that you write that in. So nothing is changing for my first fraction, so it's just x over x plus 2 times x minus 2 minus x plus 2, x minus 2 in my denominator. I have a 1 in the numerator. What was missing was x minus 2, so I need to multiply the top also by x minus 2. So I have x. Distribute the negative with the 1. So I have negative x plus 2 over x plus 2, x minus 2. And then I combine like terms. Well, when I do that, I'm just left with 2 over x plus 2, x minus 2. And that is my final answer because that's not factorable. All right, next page. Number 6. I need to factor both of those denominators. When I do that, this becomes x times x minus 2. This one becomes x plus 2, x minus 2. All right. I need to have 1 of everything I see for my LCD. So that makes my LCD a little bit longer here. Because I see an x minus 2, and an x plus 2. So for my first fraction, what's missing is an x plus 2. So I must multiply the numerator and denominator both by x plus 2 minus x times x minus 2 times x plus 2 in the denominator, 6, and what was missing there was just an x. So I need to FOIL over here on the left, and when I do that, I have x minus 2, x plus 2 in the denominator. I have x squared plus 2x plus x plus 2, and that negative goes right along with the 6x, so minus 6x. So I'm going to combine like terms. So I have x squared plus 2x plus x is plus 3x minus 6x is minus 3x plus 2x all over x times x plus, or x minus 2 plus 2, plus 2, x minus 2. It doesn't matter if you change the order because when you multiply it doesn't matter. X squared minus 3x plus 2, you need to ask yourself, are there factors of 2 that add up to 3? And the answer is yes. 1 and 2. And the last sign's positive, so the signs are the same, so it's x minus 1 over x minus 2, or x plus 2, x minus 2. Well, my x minus 2's cancel each other out, so I'm left with x minus 1 over x times x plus 2. And that, my friends, was a question that had everything involved. All right, let's look at number 7. Factors of 2 that subtract to give me 1 are 1 and 2, so I have x minus 2, x plus 1. Factors of 1 that add up to 2 are 1 and 1, so it's x plus 1, x plus 1. Now this one is a little bit different in that I have x minus 2, and we see that we have an x plus 1. Okay, we have an x, excuse me, plus 1. And if you notice in my second fraction here, I have 2 x plus 1s. But right now my LCD only has 1 x plus 1. When one fraction has a denominator that has 2 factors that are exactly the same, in this example, x plus 1 and x plus 1, I must have two x plus 1s in my LCD. I know it gets kind of confusing, but initially this x plus 1 and this first x plus 1 end up with just using just this one. If that's all I had, I would just use that one. They both share one, and then the second fraction has a second x plus 1, so I must include that in my LCD. All right, so my LCD is x minus 2, x plus 1, x plus 1. What's missing from my first fraction is an x plus 1 plus x minus 2, x plus 1, x plus 1. What's missing from my second fraction is an x minus 2. So let's see if I can fit this here. All right, when I multiply, I'll have x plus 1. This is just a positive 1, so I don't have to worry about anything, plus x minus 2. Now I combine like terms, and I have, let's see here, x minus 2, x plus 1, x plus 1. I have a 2x plus 1 minus 2, so minus 1. And that doesn't factor, so this is my final answer. All right. Rewrite as a rational expression. Well, what this means is turn into one fraction. Okay? One fraction. So we still have to find an LCD. And in this case, the only denominator I see is b, so that is my LCD. So I need to multiply both my numerator and my denominator by b. I don't have to do anything to the second fraction because it already has b. So I just write it as one fraction. All over b, I have ab plus 1 over b. And I'm done. For number 9, this one is going to be a little bit harder, not much, but I'm going to break this into two parts and look at them as they're just 3m is over 1 and 1 is over 1. And the only denominator I see is 3m plus 1. So I have to make a denominator of 3m plus 1. So I'm going to take the 3m that was there and multiply it by 3m plus 1 because that's what we multiplied the denominator by, plus, well, 3m plus 1 is my new denominator, and my numerator is also going to be 3m plus 1 because that is a 1. Anything over itself is 1, minus, I do not have to do anything to the last fraction, that's just a 2m over 3m plus 1. So I need to do some distributing here, and I will get 9m squared plus 3m plus, nothing to distribute here, 3m plus 1 minus 2m all over 3m plus 1. I'm going to combine like terms. So I have 9m squared. 3m plus 3m is 6m minus 2m is plus 4m, and then plus 1 over 3m plus 1. I'm going to save you the trouble and just let you know that 9m squared plus 4m plus 1 does not factor to 3m plus 1. All right, And there you have it. Adding and subtracting rational expressions without a common denominator can be difficult. However, if you take your time and follow all the steps, it'll be much easier for you. We will talk about this more in class.